In this video, we'll talk about the differences between the stack and the heap, and we'll also mention why destructors matter. So a little bit on both. The stack stores things like local variables and function calls, and it cleans itself automatically. While the heap, on the other hand, is where dynamic memory lives. You allocate it using new, but you have to free it using delete. If you forgot, if you forget, that memory stays reserved, causing leaks, which is pretty much memory is used up and never returned. So let's show an example on the differences and why we'll mention why destructors matter. We'll start by defining a class called myResource. Sorry, I was supposed to do Control V. And we'll open and close the class. I'll just close it right here because I've got the comments that will guide us in this video. Next, we want to set access specifier. So let's do public. The constructor and destructor will be public, which means they can be accessed outside the class. Right. So that's the public. In step 3, we want to create the constructor. So let's create the constructor, which pretty much is the same. Sorry, I was supposed to, same name as the class. Opening and closing. Yeah, we can close it here. Okay, so let's talk a little bit about this constructor, what we basically what the constructor does is it runs automatically when an object is created. Now, typically, this is where you'd want to like open a file, connect to a database, or allocate memory. But for the purpose of this video, since it is a demo of just a very like simple program, I'm just gonna write a message to the user, memory allocated, and a new line, and a semicolon to end the line. Next, I'll show you how to like recycle this code is we want to create the destructor. So the destructor is pretty much the same way that we've defined the constructor, only that we now add a tilde. And we will want to call it destructor. And this also runs automatically when the object is destroyed. And this happens either when the object goes out of scope or when delete is called. Now, do you want to use this to clean up like freeing memory or closing files? Again, for the purpose of this video, I just keep it really simple. Memory deallocated. That's the message that we want to print out to the user. Now let's go on to the main method and talk about the stack allocation. In step 5, we want to create an object on the stack. So to do that, we're going to call the class, which we called myResource. And let's call this stack object, just like so. So when main ends or the object goes out of scope, the destructor will run automatically for this object. So here we've created an object that's sitting on the stack. However, let's look at what we can do for the heap. We want to create an object on the heap, and to do that, we'll use the new keyword and store its address in a pointer. And we'll talk in a second about why we are mentioning why it has to be on a pointer. So again, myResource, I spelled it wrongly, but here. And we want to make sure it's pointer. And we'll call it heap object. Obj is equal to new myResource. This is gonna call the constructor. So the reason why it was a pointer is because the keyword new will always return a pointer to the memory it allocates. And without a pointer, you can't access, manage, or delete the memory later. And because we wanted to have this object be sitting on the heap, we need the pointer. Okay, so because it was, in this case over here, we we won't need to call the destructor for this object because this object was created on the stack. However, because this object, heap object, is created and is sitting on the heap, we need to manually get rid of it. So the object, as in heap object, obj, is on the heap, so we must manually free it by calling delete. If we don't, the destructor will never run on its own, and we could leak memory, or or have the memory leak issue. Okay, so we'll use delete, the delete keyword, and that way we would delete the objects ourselves and free up the space it is occupying. Of course, to end the program, we will return 0. So let's build and run and just show you how the constructor and destructor have been called. So in the first time when we created the object on stack, the constructor was called. And before the main ended, so somewhere we mentioned here, when main ends or the object goes out of scope, the destructor will automatically run. So after we reach this point here, then the destructor for that object was called by itself. We didn't have to call it. Whereas with so the other one as well, so the one that's sitting on the heap, that caused the constructor to be called. And when we called delete, that caused the destructor to be called again. But if we don't do this step, let's see what happens. So we should only be getting then we only would be getting the only one destructor will be called. So now we also get a warning, and that's not something to worry about for now. So just showing you how the destructor was only called the first time when it was created on the stack. This really shows that the destructor, for objects that are sitting on the stack, will be called automatically. So this call is coming from the object that's sitting on the stack. However, it was never called for the heap object that's sitting on the heap because we had to manually do it. So that's the difference between both and why destructors matter. But let's have a look at a final recap on this. In simple terms, the stack is where C++ stores temporary variables that only exist while a function is running. Think of a stack like your desk, easy to reach but limited space. The heap is a larger area of memory used for things you want to keep around longer, but you have to manage it yourself. Think of the heap like a big storage room, more space, but you have to clean up after that yourself. You got to do it yourself. So you need to manually free up the space. So I hope this was a quick video to show you the differences between stack and the heap, and stay tuned for more videos related to this. Thank you for watching.